Hi, in this video we are going to learn how to translate graphs. For a function y equals f of x, right, the graph of f of x plus a, right, is a translation of the graph y equals f of x. Now, this sentence is important because when you will be asked to describe a transformation, you should be writing translation of the graph by the vector 0 to a. Now, if you consider the vector, you know that it is very similar to the coordinates, right? So basically, this second value changes, the y value changes, or in other words, when you translate a graph y equals f of x, right, you basically and the difference here, let me talk about this. If you just add a number, you basically translate the graph vertically, up or down. It depends on whether you're adding or taking away. Now, when it comes to a change on the y-axis, up and down, you just follow whatever the sign suggests. If you add, you're going up. If you take away, you're going down. It is exactly the same as what we have here. I mean, the sign is the same as the movement. Let's see an example. For f of x is x squared times x minus 2, sketch the graph of f of x plus 2 and f of x minus 1. Now, first, let's start with the original graph. So the roots are 0 and minus 2, and there is a double root, and y-intercept is 0 as well. Hence, the graph of f of x will be something like this, right? Now, I'm going to draw the graph of f of x plus 2 like this. Just because there's an addition here outside the function, it's going to be 2 units up. So my new double root will be here, and also I'm going to have my other root move 2 units up as well. So I'm literally going to move this graph up for 2 units. So it's going to be something like this. Now, at the moment, we're not able to calculate the maximum or minimum point, so this point here and this point here, it's not important whether, you know, it's crossing the x-axis or not, alright? So we just draw it, okay? Because this is just a sketch. All that matters is, am I touching the coordinates? Did I move the coordinates of the intersection points with x and y axes up for 2 units? That's what it matters at the moment, which is, yes, I did that, right? So that's going to be y equals f of x plus 2. And when it comes to taking away 1 unit, the intersection points will move down to 1 unit, so it's going to be -1, and here I'm going to take 2 here to -1 to 2, right? It's going to be here, and my graph now will be something like this. So it basically moves up and down according to the suggestion of the signs here, and it follows suit. I mean, if it is plus, it goes up. If it is minus, it goes down. It's exactly the same as the sign suggests. Another example would be this. The blue graph is the original equation, whereas the purple one is the translated one. And you can see that the asymptote is no longer the x-axis, but it is the y equals 3 line, which you have to mention on the graph as well. So look at this example. It's a trigonometric graph, and I just move it 1 unit down because it says f of x minus 1. So basically it goes like from the original equation we just have the graph, move 1 unit down like this, something like that, right? So this is the trigonometric example, and now let's move on to what happens if we add this to the x value, like this one. So here the addition of the constant is to the x value, or this is inside the function. So let's see what happens. So for f of x is x plus x times x plus 1 squared, we're going to sketch the graph of f of x minus 1, which is inside the brackets. Now what happens is that if we have an xy table, like x values being minus 2 to 2, we get the following y values, right? So basically, if I take away 1 from those x values, so if I go like x minus 1 on the table, then when I substitute minus 2 for x, right, I will get minus 3 here. Minus 2 minus 1 is minus 3. So minus 3 will give me another y value. Or let me put it this way. If I substitute minus 1 here, then it's going to be minus 1, which is minus 2. And I know what the y value is for x equals minus 2. So basically, for this table, it is going to be minus 1, because minus 1 makes minus 2. And it's going to be 0, because if I substitute 0 here, it's going to be 0 minus 1, which is minus 1, right? And then 1, 2, 3, and so on. So basically, the x values will shift, all right, 1 unit, so that you can get the same y values. Now, what does this mean? Let's draw the original function first. So there's a double root in x equals minus 1, so it must be like this, right? Now, we will have the roots of this equation not at x equals minus 1 anymore, but x equals 0, and not x equals 0 anymore, x equals 1, right? So basically, I will be moving the roots like this, and my graph will be somewhat like this, which suggests that the graph moves right when I take away a unit, right? So actually what happens is that I move the graph this time horizontally, but opposite direction where the sign suggests. So if this is the original equation, y equals f of x, I move it 1 unit right, I end up with y equals f of x minus 1. Now the expectation probably would be that it's going to be x plus 1 because I'm moving right, but no, it's not the case. We just do the opposite of what the sign suggests. And the reason is that just because I have to substitute the different values to get the same x values here, like I have to substitute 0 to get what I was getting when I was substituting minus 1. So I'm adding 1 unit, right? That's why it moves right. Okay, so blue is the original graph, and purple is the translated one in the opposite direction of the sign. All right, another example. So this is y equals cosine x graph. Okay, and now I'm going to move it pi degrees to left because the sign suggests right, as plus, but I have to do the opposite. So it's gonna be like this. Right, so basically I just move it pi degrees to left. You can see that this point goes here, and this point goes here, and so on. That is why when we are describing this translation, we say that the graph is translation by the vector minus a to 0. Now, if you translate this into coordinates, it is minus a to 0. So basically, you're taking away, you're just applying the opposite of what the sign suggests, right? And this change is totally horizontal. Now, as this is graph drawing, there won't be an online self-check, so please do the questions in the textbook as mentioned in the blog and show your work. Thanks for watching.